Hello, hello, folks. Enter and sign in, please. So I know who you are. We'll start in about 5 minutes, but I'll be right back in a sec. Refresh your page. Oh, my bad. Sorry. Who is that? Um, Everybody be sure to say howdy so I can do attendance. So, Muhammad, Bethany, Renato. Renato, Caitlin, Harrison. Hi, Harrison. Hope everybody's staying well and healthy and all that good stuff and is staying far away from everybody else right now. Uh-oh, lost one of you. We'll wait another like 5 minutes till everybody gets here. Hey, can you all say howdy again? It looks like I lost one person. Oh, they're back. Hey, Selena. So Renato, Bethany, Mohammed, Caitlin, are you still here? Harrison, are you still here? Hi, Jordan. Harrison's still here. Rochelle, Jordan, good. Welcome, enter and sign in, please. Let me see. Oh, hey, Okura. Hey, Cynthia. Let's see. Curry. Cynthia. Hi, Jesse. Let's see. Okay. Hey, Olivia. So 1, 2, 12. Who have I lost? Let's give it about another 3 minutes and then we'll start. I hope everyone's doing well. All right, give it 2 more minutes and then we'll get started. But I'm going to ask everybody in 2 minutes. I'm going to ask everybody who's left to just give me a howdy because we've lost like 4 people. So I want to get an accurate attendance here. But let's do it in like 3 minutes, 2-3 minutes. Hi, Diana. Welcome. All right. So if everyone would go ahead right now and just type in a hello. Actually, let me count before we get there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think we're all here. Cool. Yeah, Mohammed, I've been trying to figure that out. I can't figure that out. If you can figure that out and tell me where that list is, that would be awesome. But I don't know where that list is. So we have Diane, Luis, Renato, Cynthia, uh, Okuri, Caitlin Harrison, Cynthia, Jesse. Got it. Um, Lily, are you still here? Yeah, it has participants for the chat, but it doesn't have who's still online. All right, let's just get started. All right. So first, okay. So first, I want to honor whatever questions you have. All right. So from this section, let me do one thing before we begin. Okay. I'm going to change the compound interest formula. So I don't know what page it is in your book, but we're going to change it. I don't know what happened. Okay. In the previous edition, the interest formula was good, and then they changed it. So this is the compound interest formula. Okay. Now, in the book, what they give you is this. M. They give you this. That's just bad. N here is the number of compoundings. And T is the number of years. Okay? This is the formula that's used in every single book. I don't know where in the world they came up with this, but it's just very confusing because of this M and this N, and it doesn't make sense. So just use this formula. It's easier. This is the number of compoundings. That's the number of years. Straightforward. Hold on a second. Someone's trying to get in. Give me a second. Hi, Susie. Oh, my God. Hold on. Sorry, folks. I'm helping Ernest get in. All right. Hi, Susie. Let me put you in attendance. Cool. Liliana, are you here? Yep, you are. Let me get you in. I didn't get you in attendance. Very good. Loki and Jennifer. So no Loki and no Jennifer then. Okay. All right. So here's our compound interest formula. So, what I've gone in and what I've done is go find that in your book. In the 12th edition, that's on page 692. I don't know where it is in the 13th edition, but what I would do is just go straight into your book and change it. Just cross out what's there and put in this. Okay. It's just a weird thing and it's confusing. All right. One second. I'm so sorry, folks. I'm trying to help Ernest. Okay. All right. You ready? Here we go. So we have two things we're dealing with. The one thing we're dealing with is simple interest. Okay. And that's principal times rate times time. And we'll do a couple of practices of that. Okay. All right. And the second thing we're dealing with is compound interest. Okay. Simple interest Simple interest is for when you take out a loan. All right. Compound interest is when you invest your money. Okay. It's how you earn money. Okay. It is also how you do a mortgage or your mortgage is compound interest. Okay. But we're going to get to that in a later section. All right. So, does anybody have any questions right now? I know I got a question or two about somebody not understanding or folks not understanding compound interest. So we're going to do an example of that in a second. Okay. Let me see. Let's see. Okay. So we'll do an example of that in a second. Let me do attendance. I have one more attendance to do. Wow, just about everybody's here. That's awesome. Okay, let's do an example. All right. And then I want you to type in your answer. Okay. So we're going to do this in 3 steps. 1, you buy a car for $16,000. Okay. Interest is 3.5%. And the term of the loan is 5 years. How much interest do you pay? So go ahead and do that yourselves, okay? And Ernest, you can just go ahead and text me the answer. It pops up on my computer so I can see it, okay? Okay, go ahead and type the answer when you got it. Just the interest. Okay, so we have one potential answer. Oh, it looks like everybody's getting the same potential answer. Good, Susie. Good, guys. Everybody else, are we good? Good, good, good. Awesome. Okay, that's number one, step one. Step two. What is the final payoff amount? Good, Ernest. Good. You got the same answer. Good. So the final payoff amount, right? I think that's pretty easy. That's 16,000 plus the interest. Okay, 18,800. Good. Very good. And then the third step is what's the monthly payment? What's your monthly payment? Okay. 5 years. Okay. Times 12 months per year equals 60 months. Yep, you got it. You got it, Ernest. That's how much you pay per month. Jesse and Cynthia, be sure to get those pennies in there. They really matter, particularly when we do compound interest. Don't cut off the pennies. Okay, that it really matters. It becomes a dramatic difference over time. Like we're talking hundreds of thousands of dollars. So make sure you keep those pennies. Okay. Good. I'm going to give you a problem. All right. Okay. Ready? Okay. You are given a wedding ring. Okay. That cost $12,387. Okay. The jewelry store charges 4.67% interest. You want to pay it off in 3 years. What's the monthly payment? Okay, so go ahead and solve the problem. You always, Selena, always put the full amount with the pennies. It really matters, dramatically, actually. So, yeah. Once in my calculus class in high school, we just rounded away the pennies for every step of the problem. And when we finished doing the problem, we were off by $100,000. So, of course, it was a calculus problem and it was complicated. But every time you round those pennies, the amount that you round grows and grows and grows for every next step of the problem. So you want to make sure to be as close as possible to the right answer. Ernst, your monthly payment would not be. Oh, yeah, it'd be 1,735. Is that it? Is that what you put, Ernest? Let me see. Yeah, you have a decimal problem, Ernest. You would not be paying $173,000 a month, right? So my guess is that you didn't do the percent right. Let's see what we got here. Yes, that's the correct interest. Now that's perfect. That is the interest. Now figure out how much you pay per month. Okay? So you have to do the steps, right? The steps that were on the previous page. I think I got yours, Olivia. Very good, Olivia. Yeah, I got your answer. Yes, Ernest, that's correct. That's the interest. So now you need to find the monthly payment. Ha! Okura, you did what I did. I got that answer once by mistake. I hit the calculator buttons wrong. So try it again. Good, Ernest. That's exactly correct. You got the right answer. Yeah. So try it again, Okuri. If you can see, Okuri, you missed the decimal place by 1. Good. Nope. Let me do it. All right, everybody ready? Let's do it. So step 1 is we're going to find the interest. Okay, so we should have okay. Everybody follow the steps here, right? So I did this. Now let's get the calculator out. Okay. So I have 12387 times 0.0467 equals times 3 equals. So it's 1735.42, which a lot of you got. So that's correct. That's step one. We got the interest. Step two, principal plus interest equals. Okay, so we're going to add plus 12387 equals. Our total amount then to pay off is $14,122.42. Okay, step three. Monthly payment. So we have 3 years times 12 months per year is 36 months. So $14,122.42 divided by 36 equals. So we're going to divide by 36 and we get 392.29. So that's how much your monthly payment is right there. Okay. And is that clear, folks? Are we good? Did you find where your mistakes were? Right? Are we good? Excellent. We're going to do one more. Okay? And this is from real life. Okay? A new Tesla is $79,990. Okay? Current interest rate is 4.77%. Okay? I'm going to make it a little trickier. Okay, you make a $10,000 down payment on the car. What's your monthly payment? Okay, so everybody go ahead and do that. Okay? So next time you see someone driving down the street in their brand new Tesla, you'll know how much their payment is. I see your answer, Jesse. That seems way too low. So try again. In fact, I'm going to tell you that's way too low. Like it's 5 times that amount or 4 times that amount. So I don't know where the mistake was. Good, Susie. Good, Olivia. Diane, you're off by about $40. So I don't know if you can find your mistake. Jesse, did you figure out what you did wrong? How about everybody else? Are we getting that same answer? Ah, yeah, you got to add the interest. Yeah. Good, 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 everybody. Good. All right, so you get the idea. And the bottom line is like you go buy a car, you go buy furniture, all that, anything that requires that you take out a loan with interest, you can actually figure it yourself. That's it. This is how you do it. Every time I bought a car, I do the figuring myself before I sit down and I'm within pennies. So I know what my loan's going to be, I don't need them to tell me or then I can double check to make sure that they're not cheating me. All right? Okay, so that's simple interest. Let's talk about compound interest. Okay? That's the tricky one. Okay, so compound interest. I'm going to give you an example of compound interest and then we'll talk about the formula. So if you remember, compound interest is you invest. It's also your mortgage, but we'll talk about that later. Hold on a second. Yep, you're good, Ernest, you got it. So compound interest. So that's if you invest money. Now I'm waiting for the camera to focus. Let me try it. There we go. All right. So here's an example. Okay. Here's how compound interest works. A couple of you asked me about it this week and said you just didn't get it. So watch my example and you'll see. Let's say you invest $1,000. Okay. We'll just do 1 year at 10%. Okay. Compounded quarterly. Now, this is the hard part. Okay. That means that you've you're putting, let me just run through the process and you'll see. What this means is you're putting the money in every quarter. Okay. So on January 1st, you have $1,000. That's how much you have. Okay. Then a quarter is 3 months, right? Because that's 1/4 of the year. So that's January, February, March. So on April 1st, they're going to add interest. Compounding means the number of times you add the interest in. Okay, so watch what happens here. So, step 1, figure the interest. Okay? Quarterly is 4. It means 4 times a year. Okay? A year has 12 months. So therefore, since we're gonna cut those 12 months into 4 parts, and that's 3 months each part. Okay? Figure the interest. So we have principal equals, my bad. Okay? So our interest is 10% per year. 10% of 1,000 is $100 per year. Okay. But if you notice, we're doing it after a quarter because we're compounding quarterly. So a quarter means we divide this by 4 and we get $25. So our new balance, so on April 1st, you have $1,025 in your bank account. Okay? 3 months later, April, May, June, 1st of July. So June is the 3 months, and on the 1st of July, they put the interest in. So July 1. Now watch what happens, and here it gets tricky. Okay? July 1, our starting balance is 1025. Okay? Step 1, figure the interest. Okay? So the interest would be so 10% of 1,025 is 102.50. All right? That would be for the whole year, but we're only putting it in quarterly, so we have to divide by 4. Step 2. We're going to divide by 4, and it's only in this problem because I'm just going to write because quarterly. You could compound monthly, you can compound daily. It doesn't matter. Okay? So, 102.50. So 102.50 divided by 4 equals 20. Let me hold on. I just did it. 25.63. So our new balance I did that wrong. Okay, we're good. Okay. Now July, August, September. So the 1st of October. Okay. Our balance is 1050.63. I made a mistake, I think. No, that's right. And step 1, 1050.63 times 10% is 105.06. Step 2, divide that by 4, and we get okay. Good. And now 3 more months is January 1st. Okay. We do 10% of Oh, my bad. Sorry, folks. Okay. Everybody with me? So, all right. So is that clear, folks? Let me know if it was clear what I did. That was a long process, a long, boring process. Let me know if it was clear, and if it wasn't clear, what part you didn't get. Okay, and then I'll walk. Let me walk through it again. Let me walk through the whole thing again, and then if you have any questions, we can go at it. So here's an example of compound interest. We invest $1,000 for 1 year at 10%, and we're going to compound it quarterly. That means that quarterly, every quarter, we put in our interest. Okay. So we start with $1,000. Okay. We figure the interest. The interest is 100. But since we're only putting it in for a quarter, we divide that by 4. That's $25. So after 1 quarter, where are we? After 1 quarter, we have $1,025. Good. Now here's the tricky part. And watch when I do this, okay? We're going to do it again. When we do this 10%, do you see this? We're not just taking 10% of 1,000. We're taking 10% of the interest from the first quarter, because the first quarter interest was that $25. So we're taking 10% of that $25 and 10% of the $1,000. Okay? So our interest now is more than it should be. Oops, let me get it back on the screen. Okay? 63 cents. This is why I said those pennies mattered. Okay? There's our new balance. We did it again. We did that same process again. And in the end, because we are taking interest on top of interest on top of interest, it's always, because we're doing the interest on top of interest on top of interest, right? We're earning a whole bunch more money. Now, Ernest asked if it's always 10%. It's only 10% because that's the problem I gave you. Okay? And in the real world, you would never ever get 10%. That's a gigantic amount of money. But to do the numbers, it's a lot easier to do 10% than some weird number. All right? So that's why I just chose 10% for this problem. Okay? Let me know if, just go ahead and text me or chat. Let me know if this makes sense, if you got it. Okay? Then we're going to go on and do it a different way. Let me know if it made sense to you, please. If it didn't, let me know so I can figure out which part. Oops. October notes again. Yeah. Ernest wants to do another example, and I'm going to tell him we're not going to do another example. And the reason for that is that nobody in their right mind does the math like this. I did this as an example. so that you would understand what was happening with compound interest. But I'm going to show you how to do it really fast. Okay. And then we'll do some examples of this. Okay. Cool. All right. Here we go. Are we ready, Luis? I'm going to move on a little bit. All right. So here's our compound interest formula. And you'll see this is much easier than that. That was just showing you how it works, okay, so that you knew what we were doing. But there's a formula that does this for you really fast. Our final total right there equals the principal times 1 plus rate over the number of compoundings. So P is principal. Okay. R, let me make this clear. That's 1. R is the rate. Okay. N is the number of compoundings. Per year. And T, okay. Are we good, everybody? We good? Let's put in our numbers. Okay. The number of compoundings per year was 4. The interest rate was 10%. And then this is 4 times 1. It's 1 year, 4 times per year. All right. So get out your calculator. All right. You ready? And we're going to do it now. So we do 0.1 divided by 4 equals plus 1 equals. So that's the parentheses right here. Okay. Now we have to raise it to the 4th power. Okay. Now we're going to multiply that times 1,000. And we get the same answer. $1,103.81. Everybody clear? Oh, not clear because it's out of focus. There we go. All right. Did everybody get the idea? There we go. There it does. Let's do an example. Okay. Oh, more than one more time. We're going to do a few examples. Okay. You invest $10,000. Okay. For 30 years at 5.23% interest, compounded quarterly. How much money will you have? How much money will you have in 30 years? Okay, so go ahead and do it. Here's the formula. Okay, just plug it into the formula. How much was it? Oh, duh. When you have the answer, let me know. Very good, Akuri. Other folks, keep doing until you get the answer. Holy moly, Diane, that is not correct. I wish that were correct. Actually, no, that's only $25. So try again, Diane. I think you forgot to divide by, yes, NT is 120. Harrison, I'm guessing that you forgot to divide the interest rate by 4. Right here, you have to divide the interest rate by the number of compoundings. That's my guess. Let's do it, and then we'll do a couple of more. We got about 20 minutes, so let's do this one, okay? So, here's our formula. All right, so this becomes 10,000 times 1 plus 0.0523 all over 4, like that. Is everybody good? That's what we got, okay? So now let's do it in the calculator. Okay. There we go. Let's let it focus. There, it's focused. So here we go. So we have 0.0523 divided by 4 equals plus 1 equals. Okay. Then 4 times 30 is 120. So we use our exponent key right there. To the exponent of 120 equals. Okay. Then we multiply that times 10,000. And our answer is 47,532.62. Good, Diane. Okay. Let me show you something real quick. Simple interest. Would be 10,000 times 30. And that would be okay. What I want to point out is if your investment made you simple interest, that's all you'd have. Compound interest gives you 3 times that amount. Does everybody see? So compound interest is a really, really great thing. It earns you a lot of money over time. Okay? Let's try another one. Okay? Let's say you're going to invest $8,500. Okay? For 20 years at 6.2%. And you're going to compound it daily. Okay, how many days in a year? Go ahead and do it. And I'm going to tell you that if you don't push the buttons exactly right, you're going to get error messages, but you shouldn't get an error message. It'll work. So go ahead and do that, okay? My God. Good. Hey, good. You guys got it. Or at least you got the same thing I got. Let's wait. Everybody else, it looks like Susie got 29,369.62. So let me know if you got that or what you got. Let's verify so that everybody's on the same page and we're good to go. Let me know when you got it. Go ahead and send a chat, okay? Everybody else got the same? Good, 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 good. All right, Okuri, what did you get? Zero. Let's do it together. Okay. Boy, that's bad. You lost all your money there, Okuri. Every penny you lost. All right, you ready? There you go. That's it. You got it. So we set it up like this: 8,500 times 1 plus like that. Okay? So it's 8,500 times 1 plus you need to do the exponent first. Okay? Everybody do the exponent first. Okay? And then here we go. All right. So then, oops, hit the camera. So then we have this. We have 0.062 divided by 365 equals plus 1 equals. Then we take it to the 7300th power. Then we multiply that times 8,500 and we get $29,369.62. So my point is, and this is an important thing, especially for the youngins in the audience. If you put away a small amount of money right now, meaning put away $100 every month for the next 5 to 10 years, and then leave it alone, you will have a lot of money for retirement. And speaking from the perspective of one who is about to retire, you probably want to make sure you have lots of money for retirement. So we're going to do that problem. Okay? Okay. So the average stock market return over the last 50 years is about 11%. Oops, sorry. And actually, let's be more conservative. Let's call it 8%. Okay? At age 30, okay, you have saved up $10,000. $16,000. That's 1,200 times 10. Okay, I'm going to change this again. Let's call it $12,000. That's realistic. Okay. And you invest at compound interest compounded daily for 35 years. Okay? So in other words, you'll retire at 65, right? So at age 30, you have that money put away. So for 35 years, you put it in for investment. How much do you have? On a $12,000 investment. Go ahead and do that. All right. I must have done it wrong. You guys got a different answer from me. Let me try it again. So we have 365. Oh, I know why. Yep. All right. Looks like Susie and Diane got about 197,000. Everybody else, how'd you do? Go ahead and do it till you get that. Till you get that's about the right answer. So, okay. Okay. Other folks, what'd you get? Jesse, good. You got the right answer. Everybody else? Caitlin, how are you doing? Is that what other people are getting? Give me a heads up there. Is this what other people are getting? Yes, no, maybe so. Yeah, you know what, Caitlin, I did 30 years too, and then I had to redo it. I did the same thing. That's why my answer was off. Good. Yeah, these are tricky. You have to be careful. All right. So, the moral of the story, for a $12,000 investment over life, you earn $200,000. Do you understand, everybody? So, those of you who are in your 20s, if you can see your way to putting away $100 to $50 to $100 a month somehow, whatever it might be until you're about 30, and then put it in an investment account that it just earns a basic interest compounded over time, then when you retire, you have a tremendous amount of money sitting there. That's just cash for you to use after retirement. The trick is don't touch it during the interim. It's so tempting. I'll tell you, I did it. I had a bunch saved and I had it in an account like this, and then I emptied it to take care of some business, and it was a mistake. Now that I'm at this age, I did that when I was in about 35, and now that I'm at this age, I'm kicking myself because it would have been worth a lot of money right now. And it was better that it would have been better if I just hadn't touched it. I didn't need those diamond grills then. I could have gone without them if I hadn't had those diamond studded grills. Anyway, so is everybody clear? Do we have any questions? Because right now, good. My joke. It's hard to tell jokes into the dead, land. Anyway, Diana, there's lots of accounts that you can do that you can put. There's money market accounts that earn like 6 to 8%, and you just put your money in it. Just put away the pennies, and eventually it builds up, and you have this tremendous amount of money on retirement. Okay. So if nobody has any questions, I say we're good to go. The next section, what's not working for you, Ernest? Help me out. Ernest is having some difficulties. What's not working? Did you follow this exactly? Okay. Too many questions. So continuous compounding is this. Thank you. Okuri asked about continuous compounding. That's a really good thing to look at. Let's do that real quick. Okay. E is the natural log, and it is a constant, meaning it's on your computer. So we would have Okay, let's see what we get, actually. All right. Okay, good. So here we go. So we put in, we first of all, we do 0.08 times 35. And that's 2.8. Okay. So there's our E button on the calculator. I wish it were more in focus. See if I can get it to focus there. Oh, it's worse, isn't it? All right. So what you do is you do, let's clear E. Okay. So what you get with this is you get 197,335. 76, and it's just a little bit more. So continuous compounding is just a little bit more than daily compounding. Okay? Yes, you are doing the classwork part and the homework part. Okuri, there's the formula. Why don't you try it on your calculator? Okay? And see if it works. What do the 3 dots mean, Olivia? I'm hearing a lot of whining there. Is it too much? E is the natural log, so it's a constant. It's 2.7 something. So it's just the natural log. It's a constant that occurs in nature. All right, and it comes up all over the place. So it's just a button on the computer. I wouldn't worry about it too much, or a button on your calculator. I wouldn't worry about it too much. All right. Do you have any other questions? And Ernest, why don't you hang back a second and then I can help answer your questions, okay? But you need to formulate them clearly, what it is you need from me, and then you text me and I'll do them, okay? All right, does anybody have any other questions? All right, the next section is how your credit card works. Okuri, try it again. It looks to me like you have a decimal off. Well, no. I got that same thing, but I got a 1 in front of the 97. So I'm guessing that maybe you misread the calculator or missed the 1 or something. I don't know. Try it again. It worked for me. Do we want to waive the classwork? Huh. No, it's not 2. No, it's the other way around, Okuri. It's E right here. It's this. See? Rate times time. Here's the principal. And there's the natural log. So there's the formula. I'll tell you what, we'll leave it at this. We'll leave it at this. We'll do the pacing chart work, but you're going to have a test on all of this. And so the whole point of doing homework is so that you practice so that it's comfortable. This is not a democracy. I am in charge. The so what I'm willing to say is this. Let's let the classwork slide, but if you have any issues about any of this, if this is difficult, right, then you best be doing those odd numbers in the classwork so you can practice. Okay? And then it's on you. You're going to have a test on all of this. And so you need to be prepared, right? Um, Ernest has a good question about the numeracy project. I think we talked about that last time or the time before. You're just going to turn in you'll turn in your projects to me because we won't be able to do them. We won't be able to do them publicly. So I'll just grade them. You'll turn in your PowerPoints to me. Okay. All right. Is everybody clear? So we'll waive the classwork, but I don't want your test score to go down because you didn't get enough practice. Does that make sense? The credit card problems they're time consuming, and I'm going to tell you that on your test, you're going to have a big part of your test will be credit card problem. That's going to take you forever. So you need to be really comfortable with that process. So that's one of the things I wouldn't slide over. You are welcome to, if your numeracy project doesn't work right now because you're sheltering in place, change the topic. Do whatever. I'd suggest thinking of some kind of topic that goes with working online or something. I don't even know. Yes, you got it, Okuri. There's the answer. Good. You know, yeah, yeah. I don't think there's any happy hours there. I think they're all closed. So I don't know. I don't know. What can I tell you? Come up with something. I'll pretty much accept anything just because we have this weird situation, but come up with something that requires that you gather data. And yeah, do send in a new proposal. Not a big deal. I just want to look over it to make sure that it's okay. Then let me see, Diane. If you did a portion of your project, that's great. As much of your project as you did, use that. Okay. All right. Is everybody good? All right. Go ahead and log out. And Ernest, text me your questions and let's practice. Okay. I'll give you 10 or 12 minutes. Let's practice and see what we can resolve. Okay. You know what I want to do? Okuri has a really good question about homework. Why don't you hold it all, and on the day of the quiz, just turn it all in as one email. That'll be a lot easier. I should have thought of that before, but that's a lot easier than emailing me. I'll have a million emails between all my classes. So why don't we just hold them all till the day of the quiz? That way it's just one email, one submission, okay? Everybody good? Thank you all for being so patient. We'll figure it out. All right, good night, everybody. Make sure you practice enough that you know what you're doing. Ernest, send me your question. Let's figure this out. All right. So, Ernest, we had this. We had 12,000 1 plus 0.08 over 365. And you said that you got the 365 times 35. Okay, are you with me that that's what we have, correct? Okay. So step one, we need to figure that out. So step one, okay? Step one, exponent. All right, write down the steps so you have them, okay? All right. And that exponent, when you multiply those two things together, and that you get 365 times 35 equals 12,775. Okay? All right. So we're going to rewrite it. Okay? Now, PEMDAS says you have to do the parentheses first. Okay? So you have to do the parentheses first. Do you know PEMDAS? Okay? PEMDAS is parentheses, then exponents, then that's a D, by the way. Okay, so you know PEMDAS, right? Okay. I'm only asking because last semester there are a whole bunch of people who didn't know PEMDAS and they didn't know the order of operations. So I don't assume it anymore. Okay, so we're going to do the parentheses first. In order to do the parentheses, we have to do the division first, right here. Okay? So we do. Okay? 0.08 divided by 365. Okay? And we get that. Okay? That's equal to that. Now I'm going to add 1 plus 1 equals. Good? So our parentheses now, and I'm not going to write it down because I need all of these little numbers down here. They matter. And they're going to make the thousands of dollars of difference. So we need every one of those little tiny insignificant numbers. Okay? So now I'm going to put it to this exponent. There's my parentheses, right? PEMDAS. I did the parentheses. Now I do the exponent. So there's the exponent. So I use the exponent key. 12775. And I get that. Okay? So now I've done the parentheses. I've used the exponent. Now I multiply it by the number. Multiplication and division. So you put in the wrong numbers. I'm guessing that you didn't add the 1. Try it again. So try it again and see what you got. Did you get it? Ernest, did you get it? Did I lose you? Have I lost you, Ernest? Text me a yes or a no so I know if we're still working here. It's in the message. It's in the message? I didn't see the message, sorry. Yes. Okay. Now add 1. Okay. Plus 1 equals. That's what you should have right there. That's fine. That's fine. It rounded a little bit, and that's just fine. You're good. Okay? Now, I want you to do the exponent. So go ahead and do the exponent, okay? You can hit the exponent key right here. It's usually an x to the y or a y to the x or something. It doesn't matter. Those little extra numbers where you do, but every calculator is a little different. You'll be off by $10. Okay, so let's do the exponent. And you should get that number or something pretty close. What extra keys? Are you using your phone, Ernest? Are you using your phone? If you turn your phone sideways, you'll get this keyboard. Oh, yeah, you'll need to use the X. Do you have a phone? Do you have a smartphone? Like an iPhone or an Android or something? Because all of those phones have scientific calculators just like this. On the iPhone, you turn it sideways. Oh, then turn it sideways and you'll have all the keys that I have. Did you turn it sideways? There you go. How are we doing? So when you get that, you're going to hit this key right here, okay, which says x to the y, x with a y exponent. Hit that key and then type in 12775. And then hit equals, and you should get this number. Excellent. Excellent. So now that's this to this exponent. Now multiply it by 12,000 times 12, 1, 2, 3 equals. And there you go. Did you get it? Did we get it there, Ernest? By the principal, 12,000. You multiply it by 12,000. Excellent. I'm going to suggest that we do another. I'm going to give you another problem right now, and we'll do it so you know how to do it, okay? So we do it again so that it's strengthened. So here we go. You invest $15,000 at 5.6% interest, compounded monthly, okay, for 20 years. Okay? So you would rewrite this like this. So I want you to do this one for me, okay? So do that one. Okay, use your calculator and find out what that is. Okay. Let me know when you get your answer there. Okay? How are we doing there, Ernest? No, I can't do it. Did I lose you? Ernest, did I lose you? Are you still there? You forgot to add the 1. You forgot to add the 1. So do it again, but you add the 1. So you do 0.056 divided by 12 plus 1. How are we doing? Are you still there? I have a feeling I lost you. Are you still there? I'll give it another 20. There you go. Okay. What is the delay? What's going on that's taking so long? Because this should be a couple of buttons to hit and you're done. So help me out with where the difficulty is, because I need help me out here, Ernest, because this is pretty straightforward. All right. I'm going to do it for you and then we're done. So why don't you watch? We'll do it together. Okay. 0.056 divided by 12. So do that for me. Okay. And then send me a text when you got that. Okay. Well, we can just do it by text. There we go. Do you have that right there? Point 0.056 divided by 12. Good. Now we do plus 1 equals. Okay, is that what you got? Good. Now, 12 times 20 is 240, so we hit the x to the y key, 240 equals. And tell me when you got that. Are we good? Did you get that? Yes. So you hit the x to the y key, 240. And you should get this number. Good. Now we're going to multiply by 15,000 times 15123 equals. And there's our answer. Very good. Are we good there? Let me see. What do we got? I missed that. Ernest, none of us are online students. We're just trying to figure it out. Okay, there's really no other option at this point. We're all doing our best. Okay, I'm not an online teacher. We are all doing our very, very best in a difficult situation. All right, we got that answer? Yes? Yes, no? Yes, no, yes, no. Good. All right. Well, I'm going to check out for the night then. All right. We will see you then on Thursday. All right. Good night.